Physics, Chapter 19, Theory Video 8. We are going to discuss about frequency and angular frequency. So this is a completely new lesson, new part, and this has not been discussed. There are the basics, of course, have been discussed, but you have not met angular frequency related to SHM, simple harmonic motion, in your O levels or in your AS level. So this is something entirely new, but not very different. But there are some combinations or references to some of the earlier lessons. So don't actually don't be misled or don't confuse. For example, here there is the reference to omega, right? So we have learned a different omega earlier, so that is not relevant to SHM. So SHM omega is something entirely different. Remember it like that. There are some comparable points, but remember them as different aspects. The frequency f of SHM, simple harmonic motion, is equal to the number of oscillations per unit time. So that is obvious. The number of oscillations per unit time is the frequency. So the f is equal to 1 upon t. That is an equation that we have learned earlier. So if you take a complete oscillation of an oscillator, now for example, if a pendulum, here we are talking about a pendulum, but this is not a specifically, you saw that simple harmonic motion can exist in a straight line. There is no reference to a circle. But if you take a pendulum, right, we can actually make a comparison, right, that a single oscillation or one complete oscillation is equal to 2 pi radians. That is a single cycle of one complete circle, right? So 2 pi radians is how much it would go in a complete circle, right? Then it is in SHM also, a complete oscillation is equal to 2 pi radians. So that means in one oscillation, the phase of the oscillation would change by 2 pi rad, right? So that means if there are f oscillations in unit time, there must be 2 pi f rad in that unit time, right? So that means, basically what basically happens is, a single oscillation, right? Let's say going past and this point, back and forth. So back and forth means it goes here, comes back, goes here and comes back, right? Go backwards. So that is how it happens. So one single oscillation is equal to 2 pi rad, right? So we have 2 pi rad in one single oscillation. So if there are f number of oscillations in unit time, there would be 2 pi f rads in that particular unit time. So this is referred to as angular frequency and is taken by omega, and that omega is angular frequency, right? Then angular frequency omega is equal to 2 pi f, right? Angular, so this equation is what you need to remember. Because f equals to 1 upon t, you can then substitute, instead of f, you can substitute 1 upon t. Then omega is equal to 2 pi upon t. Then through that we can obtain the period to be 2 pi upon omega. Omega stands for the angular frequency, 2 pi f. So there are basically two equations that you need to remember. Pi equals omega equals 2 pi f, and then t equals 2 pi upon omega, or omega equals 2 pi upon t, depending on the situation. But that is the same variation of omega equals 2 pi upon t, right? So those two equations you must know. In figure 19.17, a single cycle of SHM is shown, but with the x-axis marked with the phase of the motion in radians, right? So here you can see quarter of the oscillation is pi upon 2, then half is pi, 3 pi upon 2, and then 2 pi, the whole thing. That is how the phase would change. I hope you understood that, right? So that is the theory explanation for that. Write down a note. Frequency and angular frequency. Frequency of SHM is the number of oscillations per unit time in SHM. A single oscillation is considered to be similar to one whole circle of circular motion, which is equal to 2 pi radians or 2 pi rad. Leave a line and write. In other words, the phase of the oscillation changes by 2 pi rad during one oscillation. If there are f oscillations in unit time, f number of oscillations in unit time, there would be 2 pi f radians in unit time. This quantity is defined as the angular frequency, within brackets omega. Leave a line and write. Because f equals 1 upon t, we can substitute 1 upon t to the equation of angular frequency as follows. And then write down, this is the equation for angular frequency, and then substitute for f, substitute 1 upon t, and then show how these two would come. And when after you have written down those two, draw this graph to show how the phase would change during a single cycle of simple harmonic motion. I hope you understood. If you did not, please ask me questions. If you did understand, please do question number 11, 12 and 13.